Okay, so now we're going to take a look at how to find the angle between two vectors, and all we're doing is taking our formula that we have for the definition of a dot product, which was the magnitude of A and B and the magnitude B. We're going to divide both sides by those magnitudes, okay, and that's how we get the formula below. All we're doing is dividing out these cancel, okay, and we're left with A dot B over the magnitude of A and the magnitude of B. Okay, so when we have a Cartesian or geometric vectors, we can find the angle in between these vectors by finding the two vectors and then doing cos of theta for them. Okay, so we'll take a look at this example here. So here's the example. We've got two vectors, s and t, and we just need to find, if we want to find the angle between the two, wherever they are. Okay, so cos of theta then is going to equal s dotted with t over the magnitude of s times the magnitude of t. Okay, so, and remember, s dotted with t, when we have the components this way, is 5, 1 dotted with -3, 8. And we take our components 5 times -3 plus 1 times 8. Okay, and we get -15 plus 8, which equals -7. Okay, so we have that as -7 in the numerator. Finding the magnitude of each vector should be pretty straightforward now. So square root of, and again 5 squared plus 1 squared, so it gives us the square root of 26, and the magnitude of t then is equal to the square root of -3 squared, oops, that shouldn't go there, just put the bracket first, okay, and plus 8 squared, okay, which then gives us the square root of 73. So we found those, and we can put these all in. Square root of 26 times square root of 73, and we're looking for cos of theta, and then theta is equal to, and you don't need to work this out until the end. You can do all of this on your calculators, okay, without having to get decimals and write down all these numbers. Just do it this way, type it all in at once, and we should be getting 99.2 degrees. Okay, so check that with your calculators, make sure you're getting the same answer. Here's example 4, and we've got the vertices of a parallelogram ABCD are A, B, and C, and again these are vertices, so these are points somewhere in space, these aren't vectors, okay? But we can determine the coordinates of D, and we're going to use vector methods for this, okay? So there are other ways to do this, but we're going to do this with vector methods because that's what we've been doing, okay? So we're going to use vector methods. And really, since we have a parallelogram here, we can set up our vectors, so AB, and we can have DC as well, okay? When you set this up in this way, what you're saying is that my vector AB should be equal to the vector DC if this is parallelogram, okay? So we have the 3 points, A, B, and C, that are kind of given to us, and D needs to satisfy that the vector AB has to equal DC, okay? And remember now, we subtract the head from the tail when we do these, so we go in the right direction and we get things set up properly, okay? So AB, we'll get AB first here, is equal to my vector, okay? We'll do the subtraction for this. We are going in this direction with that, so -3 minus the -8, which gives us the +5, okay, for our first component, and then 4 minus the -3, which will give us 7, okay? So be careful with those negative signs and the directions in which you get your vectors, okay? Now, DC, we know half of DC, or we know part of DC. So DC is going to equal, and we can write this down as if the coordinates of D are x, y, okay, so we don't know what they are, but we know C. And C is the tail of this, so we're going to subtract 8 minus x, whatever our x component is, and then we'll have a negative 2 minus y for whatever that component is for D, okay? Okay, so we know now that AB has to equal our DC. Okay, we know that each component part. So when I look at each component, I know my vertical has to equal this, my horizontal has to equal that. Okay, so we can set up our equations here, and we would get that 5 equals 8 minus x, okay, and 7 has to equal negative 2 minus y. Okay, so now we can rearrange, and we'll get that x is going to equal 3, okay, and your y is negative 9, just like that. Okay, so therefore we found our D, and D is equal to 3 comma negative 9. Okay, so that's part A. And determine the angle between the diagonals. We'll take a look at that in a second, okay? Okay, so for part B, again, we're going to find the angle between them, whichever vectors you want to take. So we'll look at, we can do AC now dotted with DB, and AC and AB. So whichever vectors, whichever directions you want to go in, just make sure you're doing the diagonals. So for my diagonals, we're going across this way. Okay, so either like this and like this. And remember that regardless of where these are, okay, the angles we're finding, remember, is the same as tail to tail. But that angle in there will now equal this angle in here, okay? So we can look at it that way, but we could find it tail to tail by getting those vectors that way, okay? So when we find the angles, remember they're tail to tail. But because of the way this is, wherever they cross, we have that kind of same pattern because of the parallelogram law. Okay, so cos of theta will take our two vectors, in this case AC, and dotted with dB, over the magnitude of AC, dotted with the magnitude, or times the magnitude of dB. So there we're doing our scalar, so we do multiplication there, okay? So that'll equal, and I'm just going to work these ones out, okay? So when we do our subtraction and everything, you guys can check the values for these. But AC, it'll be 16 times negative 6 plus 1 times 13 all over square root of 257 times square root of 205. Okay, and that'll give us negative 83 over 229. Okay, and theta then is equal to cos inverse of that, which equals 111.2 degrees. Okay, so our angle in there, and when you're looking at the angles in there, we can zoom in on this part in here, and that'll be the 111.2. Okay, and then depending which angle they're asking for, you can find the 180 minus to find the other angle. Okay, so I'm just keeping it off of here right now, just to save time with the videos. Okay, but we can go through that if you have questions when I get back. All right.